Hello, my lovely viewers and my dear students. This is Miss Ruchika welcoming you to yet another video for my grade 9 students. So, today's topic that we are going to be covering in this session is from Module 8, Lesson 4, and the topic is Transforming Exponential Expressions. Let's get to know your learning outcomes. In today's session, you will be using the properties of exponents to transform expressions for exponential functions. So, if you are liking my videos, please do share, subscribe, and like them. And don't forget to press the bell icon before proceeding further for the video. Let's get started. Okay, so before we move further in the lesson, let's recall from our previous classes about exponential growth. So the formula that we have been using is y equal to a multiplied with 1 plus r to the power t. Let's identify and recall the variables. So a here refers to the initial amount. So it can be amount of a money lent to a bank, or it can be some amount that you invest somewhere. So initial amount is represented by a. Then your R represents the rate of growth. So here, because it's a growth problem that we are going to be looking at, so it will represent rate of growth. If it was a decay problem, R would represent the rate of decay. Now this rate of growth, usually we take it in decimal. So if, for example, the rate of growth is given in a question as 5%, then you are going to convert it into decimal after dividing by 100. So you'll write 0.05. So this will become the rate. So just remember that this rate that we are taking is in decimal. Next is your t, which represents the time. Now this time, whether we are going to have a problem based on compound interest accordingly will vary. And if it is a compound interest problem, then we are going to also refer to one more term, which is n, which here would represent the compounding frequency. So in that case, we will change our value of n accordingly. So as you may proceed in the lesson, you will see that we might sometimes use the formula amount is equal to principal multiplied with 1 plus r divided by this n and then raised to the power nt. So if it is a bank problem where the money is involved is invested in a bank and we are trying to compare the interest generated, then we might have problems which have words like monthly, daily, or compounded annually, all of that mentioned. So we missed an L here, L and Y. Yeah. So it can be depending upon how much and for how long the interest is compounded. So if it is compounded daily, N will change. If it is monthly, yearly, annually, all of these terms will come in the word problem when you get such in this lesson, or otherwise also when you are using the compound interest situation. So let's now go and see what kind of questions can be expected from this lesson. So basically in this lesson, as you would see in the slides to come, a question can come where you need to compare two situations. So if it is about bank accounts, if you're talking about money, if you're talking about interest, savings account and all of that, then we need to compare the rates with the same compounding frequency. Means what? So if the compounding frequency is say monthly, that means after the end of each month we are doing the calculation of interest. In that case, we will be comparing both the banks or both the accounts that we are handling here on a monthly basis. So we look at the monthly rate of interest. If it is annually, then we will look at the annual rate of interest. If it is daily, then we'll look at the daily rate of interest. So depending upon the compounding frequency, after how much time the interest is calculated, you will see whether it is monthly or whether it is say annually. or daily. So this is important point. So accordingly, when you are doing the comparison, you're going to compare the rates in this basis. So one way to do that is to compare the approximate monthly interest rate. So in part A of the question, if you have to compare the monthly rates, then for both the banks, for example, there is one bank A and bank B. So when you are comparing the rate of interest, definitely your starting point would be the equation which we just saw in the last slide, which represents your exponential growth. But in this case, since it is written in the question, it is quite clearly mentioned that we are looking at monthly rates. So you are going to compare your R accordingly. So whether it is bank A or bank B, whichever is definitely going to give you more interest, you are going to choose that. Okay, that was monthly. Second is annually. So sometimes you may be given for one bank the rate of interest in monthly terms, for another in annual terms. So before you start comparing their interest rate, you have to calculate something called as effective monthly interest rate. So when you are comparing, both have to be in the same compounding frequency. So if you are doing a interest calculation every month and you want to see which bank is offering you more interest, you are going to look at their monthly rates and then compare. Similarly, for annually, you are going to compare annually. So it all depends what the question is asking you. Okay, so let's have one example. This is our first example for today, in which you will write the equivalent exponential expression. So definitely I'm again writing the same formula. This is your starting point, just to remind. So let's read the word problem. Lactobacillus acidophilus is a bacteria used in the production of yogurt and some cheese. It has a growth rate of this percent. Now I'm highlighting here important information. The word growth tells you that you have to use this formula for exponential growth. Now how this bacteria is growing, there's a rate given. So I'm going to highlight the rate also, 0.92%. And what is the compounding time? It's growing by 0.92% every minute, per minute, in 1 minute. Okay, that's the first bacteria. So maybe I write it as B1. I've highlighted, and the second bacteria which you see here, so B2, is Bacillus megaterranium, and this is synthesized to create penicillin and has growth rate of this much. So a lot of scientific information, we are not going to look much into that, but yes, we are more concerned with the numbers here. So let's look at the mathematical part of it. So what we need to do here, we definitely need to do a comparison. And how do you know that that comparison has to be done? Because the question is asking you to determine which bacteria has faster growth rate. Now, if you look carefully into the percentages given here, for bacteria 1, you are given the percentage in minute, whereas for bacteria 2, you are given the percentage in second. So both are different units. So it's not easy for us to compare as of now. So in order to compare well, I'm just making a rough table here. B1 is bacteria 1, B2 is bacteria 2. So 0.92%. This is per minute. So in 1 minute, it is growing by this much percent. And the second bacteria, for this, the unit is different. It is per second. So in order to be better comparing this growth rate, we have to convert them into 1 unit. So then it will be a good comparison. So the part A of the question says, drag each equation next to the corresponding step to write a function to represent the amount of Bacillus megaterranium, which is your B2. So Y is referring to the amount of this bacteria that would be present after t seconds. So t here is in unit of seconds, using the effective growth rate per minute. Okay, so that's part A, and I'm sure you are able to observe that for this bacteria, let's go to B2. It was given in which unit? Per second. So we need to convert it into per minute for sure. Only then we will be able to compare, only then we will be able to say which one has a faster growth rate. So definitely in this lesson, we'll be having questions and word problems where we are going to write equivalent exponential expressions and thereby compare two things. Okay, so let's start with solving the question. Our starting point will be the equation of exponential growth, y equal to a multiplied with 1 plus r to the power t. Now, in order to successfully compare and in order to use the same units of minutes and seconds, we will, for ease of calculation, take our initial amount to be 1. So this A will be replaced with 1. Now, for the seconds, the rate of growth is given as 0.046% for the second bacteria. So this percentage, as I had told you when I wrote the formula, this rate of interest will be always given as a part of decimal. So you convert it into decimal. I hope you know how to do that. So this 0.046, it's in percentage, means it's divided by 100. Now in order to put this in decimal, or in order to remove the percentage, we will move, because the denominator has two zeros, we'll move to the left by 2 units. So this is what is going to be the new decimal. So we plug in place of r this value here, t is as it is, and on simplification, adding 1 to this, you get this step. Okay, now this is what you have in per second unit, because when we started with the rate, it was 0.046% per second. And in order to successfully compare the two bacteria, B1 and B2, they need to be in the same unit. And for the first bacteria B1, the rate of growth was given in per minute, that was 0.92%. So therefore we will simplify. After this simplification, we'll try to convert this rate of interest also in the same unit. So because it was in seconds and we want to convert to minute, and I hope you all know that 1 minute has 60 seconds. So the conversion factor that we'll be using here will be this 1 minute we are going to convert into 60 multiplied and 60 divided. So it's the same thing, right? So we are replacing now the power t with 60 multiplied with 1 by 60. Okay. Now, why we are doing this? So that we can include a part of this power inside for this number 1.0046, and when we do that, the remaining power that will be left, because we are applying power of a power rule. So what does that say? That if you have an exponent with two powers, so one is m, another is n, then it is same as multiplying those two powers. So actually we did the opposite here. The two powers were multiplied, so we separated them, one inside the bracket, one outside the bracket. And why we did this 60 only? Because 1 minute has 60 seconds. We are going from seconds to minute, and that's why we break them the power in this way. Now this outside power will be as it is, it will be here, whereas this inside one, which is 1.0046 to the power 60, is a very big power. So you may use a calculator here, and even after using the calculator, since the power is too big, the value that you will be getting will be an approximate value. So approximately this value comes out to be near about. So this symbol is near about. It's not an exact value. Remember, it's approximate 1.028. So that means 1.028 is the rate of interest when we have done the conversion for bacteria 2. We are looking at bacteria 2, and now it is no longer in seconds, it is per minute. So this is how the comparison has been done. Okay, so let's solve this problem now, part B of the question. So for Lactobacillus acidophilus, we are doing this calculation. That was our bacteria 1 chosen. And because we need to say the amount which is left that will be present after t times, we are using the same expression of exponential growth. Now some things I hope you have already understood by now, that for ease of calculation, we take initial amount as 1. Rate is given to you in the problem already as 0.92. This was percent given in minutes, so I'm going to convert to decimal by dividing by 100. Time is as it is. So this reduces to 1 plus 0 point, decimal shifts 2 places, so 0092. Now I can combine, just add 1 here, so 0092, and this was taken for the bacteria B1 in the unit of minutes, because if you remember the part of the statement of the question, it said 0.92% per minute. That's the rate of growth given in the word problem. Now in this question, the trick is it is asking 40 minutes using effective growth rate per second. So you have to change this growth rate, and the conversion factor would be similar. You know 1 minute is having 60 seconds. So in order to do the conversion, we do exactly the same thing we did in the last part. We multiply with 60, we divide by 60. But there'll be a slight difference here because now we are doing the conversion from minutes to seconds. So with this value 1.0092, this time you are taking the 60th root, and outside you are left with 60t. Now if you do this calculation, approximately this will come out to be 1.000152. It's a complex calculation, so you may use your calculator, and then you are left with 60t. So this is your effective growth rate per second. So if you want to just uh, you have your answer already now, A part, but if you want to do a little more research, then you can break this in 1 plus R form. Means your R is exactly 0.000152. So if you convert into percentage, you move to decimal place, so 0.0152%. That's the rate of growth. Now we have converted from minutes to seconds. And as you can see here, this rate of growth is very, very less. If you even compare it with 0.046%, which was the rate of growth for the second bacteria. So definitely without even solving any further, we know that the rate of growth of bacteria B2 is higher. Okay, so let's do a little more calculation here. Now we need to just summarize, and now I'm just going to draw the table for the two bacteria one more time and summarize the solution. In the last part, we already concluded that B2 has a higher rate, and now we are going to compare them one by one. So for B2 in the question, it was mentioned 0.046%. This was when we were using the unit of seconds. And for B1 in the question, it was mentioned 0.92%, and this was per minute. Now in part 1 and part 2, the first parts A and B, you have concluded that for the bacteria B1 and for bacteria B2, the rates of interest accordingly. So for this one, for B2, it came out when we did in minutes as 2.8% per minute. So it's definitely quite a large value. And in a similar way, for B1, it came out to be lesser than this value. So it was something 0.00. Now I'm not remembering the exact value, but definitely this value was lesser than what was in B1. So in both the cases, whether it is per second or per minute, if we are comparing the rate of growth, B2 is always at a higher. So definitely Bacillus megaterranium, this bacteria is going to win, and it is the one which is growing faster. Okay, so let's do one more question. This is now a bank question. So this person called Tariq, again it's a word problem. Let's highlight important information. He's planning to invest some money in a savings bank. So this lesson is quite useful for anyone trying to do some investment. And he has two options to choose. One is the Oak Hills Financial Bank, which is offering him 3.1 interest. This is done annually, so once a year. And the second bank, so I'll just number 1 and 2 here, because eventually as we proceed, we have to compare these two banks in terms of the rate of interest that they offer. So for First City Bank, the saving account which he's going to open, they do the interest calculation quarterly, and the rate of interest is 0.7%. So I've just highlighted the two rates of interest here. So there are two parts to the question. In part A, you need to write a function AT that represents the balance of a savings account after T years to Oak Hills Financial. So that means from the first one, and here, because for Oak Hills, if you see carefully, question says it's compounded annually. So one time in a year, and here it is quarterly, means one quarter as out of 12 months. If we select one quarter is 4 months, so that means interest calculation will be done after every 4 months. So this is quite important. So before we start solving part A, we need to bring both the banks in the same unit. Means we need to also convert Oak Hills, which was doing an annual calculation, it was compounding interest one time in a year, to quarterly, so that you can compare their rates of interest effectively. So again, this is a question on comparison, and the two units that we are looking here, like in the previous question where we had the bacterias, we were comparing their growth rate in as a measure of time. So here for B1, which is bank 1, B2, which is bank 2, the two units of comparison would be one which is annually, once a year, and another one which is quarterly. So after every 4 months, the interest will be calculated. So let's write what is given, and then we'll fill in the missing blanks one by one. So for the first bank, which is Oaks Hill Financial B1, which I've taken here, let me write B1, and this one is B2, First Cry Bank. So these are the two. So for first one, Oak Hills, you are given 3.1%, and that is annually. So I'm going to fill in here. That means I need to find for this bank the quarterly, which is what is asked in part A if you read carefully. So for Oak Hills Financial, you need to see what is the interest rate when you are compounding quarterly. That will miss this filling question mark. And for the second bank, which is here First City Bank, you are given the quarterly compounded rate of interest, which is, so I'm going to fill this part here, 0.7%, and then later towards the next part of the question you will be asked to fill in these two question marks, and you will look at the second bank, First Cry Bank, and you'll have to calculate its annual rate of interest. So I hope this question makes sense and you've got an idea how to solve. I'll give you some time to solve it, and then we'll discuss in a few minutes. Okay, so now that we understand the problem well, let's try and solve it. So we are going to now write the function AT that will represent the balance of the saving account after T years through the Oaks Hills Financial. That means we are looking at the first bank, and the interest here needs to be compounded quarterly. So let's go back to the problem. In the problem, it was mentioned that Oak Hills, or the first bank, is giving 3.1 annual rate of interest. So this is annual, once a year. We have to convert it into a quarter. So let's use the formula y equal to a multiplied with 1 r over t. Now here we need amount, so we're replacing y with at. At is the amount that the bank is going to give after the interest is calculated, compounded quarterly. So for ease of calculation, we take the initial amount as 1 again. 1 plus, let's plug in the values, so 3.1% over time. Again, the rate of interest has to be decimal, so we are going to change it to 1.0. Divide by 100, 0.3, 2 decimals. That's good enough. So this comes out to be 1.03. Just add 1 to it, and you get this. Now we are dealing with quarters. So the interest that we used till now was annual for 1 year. We need to convert it into a quarter, that is 4 months. So because 1 quarter has 4 months, so let's use that number. So we will multiply with 4 and we will divide by 4, just like we did in the last problem. So here now I have to isolate 1.03. I take this with the fraction 1 by 4, and 4 multiplied with t is outside. So when you do that calculation, this quarterly rate comes out to be approximately 1.00 0.77 and it has a power 40. So that's your answer for this part where you got your 80, and definitely it's not an equal value, it's an approximate value since we are looking at the fourth root. Now from this part, let's also do one more thing. We got 3.1% that was given in the question as the annual rate. Let's find the approximate effective quarterly rate also. So I'm going to write here, this is not asked in the question, but just for the sense of good comparison, let's do this also. So the effective quarterly interest rate, and we are talking about the Oak Hills Bank. For Oak Hills, we are doing this thing. It is going to be equal to this decimal, so 0.0077. And now if I want to convert into percentage, I move two decimal places. Approximately it is 0.77%. So you actually got the quarterly interest rate that was taken by Oak Hill. So it's an additional thing, but it's a good number to compare in the next step. Now we are going to do a similar comparison. So the part B already we have got. So round it off to the nearest hundreds means 2 decimal places. So this is what we had actually done in part A. So we'll just round it off and give it as 0.77%. Now we will complete the table of values. So if you now compare the chart which I had drawn before, I'm going to just quickly draw it here. So B1 first bank, B2 second bank. So here we are referring to Oak Hills, and here we are referring to First Cry. So these are the two banks we are comparing, and when we did an annual comparison, Oak Hills was 3.1%. This is given in the question. And First Cry was 0.7%. This was also given. And in just this part B, which we solved, we got for Oak Hills the rate for compounding quarterly. So I will mention that also. This is for quarterly and this is for annually. So looks like till now Oak Hills is leading. It is giving more interest rate. So Tariq is definitely going to get a savings account in this bank because he will be getting more interest. Now let's be double sure and finish this value also. So I'm going to do this an additional part. It was not asked in the question, but just for your better understanding, so that you know how this knowledge of exponential functions and how knowledge of your growth rates is very useful. So 1 plus, now I'm going to use this value. So I'm going from quarterly to annually. So 0.7%. This calculation is being done for the second bank now, First Cry. So what is going to be this value? So again, we convert to decimal 0.007. And before I proceed further, I'm just adding the same step here. So this is 1.007, but this time because we are going from quarterly to annually, we will take 4 power inside and outside will be t by 4. So roughly this comes out to be 1.028. Oh, I'm running out of space now, but I'm sure you are able to observe here that when we come to this bank, First Cry, the effective rate of interest is near about, so it is 0.028 in decimal. So let's convert to percentage for a better comparison, 2.8. So now we are double sure. We can see that here definitely First Cry Bank or the second bank is giving quite a less rate of interest when we compare to Oak Hills. So now we are confident that Tariq is going to choose Oak Hills as his bank. It's a better bank for Tariq to open his savings account. So I hope this session was useful. This was the last question for the session today. And though the questions are pretty long, these are word problems, but really important. And you can see very well how the comparison can be done between two things using your knowledge of exponents using your knowledge of exponential growth. So that wraps up our topic for today, transforming exponential expressions, where we did good comparison between the rate of growth of two objects. If you liked the video, give it a thumbs up. Don't forget to like, share and subscribe. Until then, this is Ms. Ruchika signing off from today's session. All the best, grade 9, for your coming exams. See you in my next video. Bye-bye.